Chapter 2, Section 3, moving on to master for volume. Just like what we did with surface area, we're going to take formulas, but in this case formulas for volumes of different shapes, and we're just going to do some algebra and isolate different variables. That's all. And you might find these actually a little bit easier than the previous section. So I have the volume of a cylinder, which you've seen is the area of the circular base, or pi r squared, times h. Here we want to solve for h and r. So think of this as just two separate questions. So I'll leave myself some room. So the volume is pi r squared h. And if I want to solve for h, well, that's easy. I just need to divide both sides by pi r squared. There we go. Whoops. Little mistake there. Fix that. Pi r squared. And of course, on the right-hand side, all that mess cancels out. So I'm just left with h. So let's say h, meaning the height of a cylinder, is equal to its volume divided by the area of the base, which I would hope makes sense. So that's formula number one. Next, it wants us to solve for r. And here, I'll put a split here. And I'm going to begin with the original formula. So this is the volume again. But I want r. So this requires me to divide out the pi times h. Okay. So like before, we get some cancellations. So those go. But I'm not quite done, because I haven't solved for r yet. I've just solved for r squared. So the square of the radius is the volume divided by pi h. But I want r. So the only way to get r is to effectively take the square root of both sides. So r is the square root of this entire mess. Volume over pi times height. And I'll put that in a box. Okay. So you're not expected to memorize these formulas, but on an exam, you would of course be given this one, and you would be expected to be able to manipulate them and solve for either of these variables on your own. Let's try a couple more. The volume of a square pyramid is 1/3 times the area of the base, which is b squared, times h. Let's solve for h. Okay. Well, some people, when they see a fraction, they get scared. But remember, when you're multiplying by 1/3, that's exactly the same as just taking b squared h and then dividing it by 3. So if it makes more sense to rewrite the formula this way, by all means. So that's volume is b squared h all divided by 3. Okay. Maybe that will be easier to work with. So we want to isolate h first. Okay, well, I need to get rid of this 3, so I'm going to multiply both sides by 3. Be careful not to put this 3 on the bottom. You can either put it in the middle or on top here. And then I'm going to multiply that by 3. That's just 3v. And now these cancel away. 3 divided by 3 is 1. So now I have 3 times the volume is equal to b squared h. But to solve for h, I now need to divide out the b squared. So that cancels. And with that, I believe I'm done. So the height of a square pyramid is triple its volume, all divided by the area of the base, or b squared. There we are. Now let's do the same thing again, but we're going to solve for b, the base. So let's put a split here. Let's do that. So begin with the original formula, but I'm going to put it as I did here. I'm just going to divide the whole thing by 3. So this is v equals b squared h over 3. So the first step is just a repeat of what I did before. I'm going to get rid of this division of 3 by multiplying both sides by 3. Again, make sure this 3 does not go on the bottom, because then you've actually divided by 3, and we don't want that. So those cancel. So this is 3v equals b squared h. But this time I want to solve for b. So that requires me to divide out the h. That's pretty easy. So that cancels. So now I have the base squared. Again, this is just the area of the bottom, b times b. That's equal to 3v over h. But again, I want b, not b squared. So it's just like this formula over here when I was working with the cylinder. So b, okay, is the square root of this junk right there. 3 times the volume divided by h. I'll put that in a box. And there we are. All right, one more. The volume of a sphere, solve for r. So you've seen before that the volume of a sphere is 4/3 times pi times the radius cubed. Well, really the only variable here is r. So that's really the only other letter I could isolate as opposed to v. So volume is 4 times pi times the radius cubed, all divided by 3. It means the same thing. Maybe this is easier for you to work with. Maybe it isn't. So I want to get r by itself. So I need to get rid of this 3. So I'm going to multiply both sides. Now that cancels. So this is 3 times the volume is 4 pi r cubed. So I need to work to isolate r. That's easily done by dividing both sides by 4 pi. So that just disappears and becomes 1. So the radius cubed is 3 times v divided by 4 times pi. There we go. However, this is not a square, this is a cube. So how do you undo cubing a number? Well, here I had an r squared and a b squared. So to recover r and b, I took the square root. Well, if I want to recover a cube, we take what's called the cube root. What does that look like? Well, in short, it looks like this. So the radius would be, and we're going to write this radical symbol here, but to make it distinct from a square root, we're just going to put a little 3 here. And you're going to learn later that that's called the index. So I put a little 3 here in that radical. So this is 3v over 4 pi. Remember, that 3 has to be small. It shouldn't be a 3 multiplying this whole thing, because that would say something else. I'll put that in a box. Okay. So the radius of a sphere is 3 times its volume divided by 4 pi, and then you just take the cube root of that number. Okay, so question 1 asks us to determine the radius of a cylinder of height 4 centimeters and a volume of 539.3 cubic centimeters. Okay, well, we've already worked out this formula before. We know that the radius of a cylinder is the square root of the volume divided by pi times h. Well, I have all this information that I need. So I'm just going to put that all in. So the volume here is 539.3 cubic centimeters divided by, make sure this square root symbol includes everything, pi times, and my height, that's 4 centimeters. Okay, so what you're going to do is you're going to take your calculator and you're going to work out everything that's inside here, and then you're going to take the square root. Okay, so 539.3 divided by, and you're going to want to use brackets here, otherwise your calculator is probably not going to give you the right answer. So I'm going to divide by pi times 4. I'm going to close that bracket. Okay, now in my display I have the number 42.916 blah 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 blah, and then I'm going to take the square root of that. And that's going to give me, not a very nice number, but 6.55, and of course this is now in centimeters. So I'll put that R here. All right, so that is the radius of my cylinder. Wasn't so hard. Number 2, determine the length of a rectangular prism, or just a box, of width 6.2 meters and height 4.7 meters, and a volume of 346.8 cubic meters. All right, well, the volume of a box is simply its length times its width times its height. But it's the length that we're after. So I'm going to divide both sides by WH. So that cancels here. So the length of a box is just its volume divided by WH. Okay, so these three variables are already given. So this is 346.8 cubic meters, and that's being divided by the width and height, so that's 6.2 meters times 4.7 meters. And again, when you're working this out on your calculator, be careful with the bottom here, because if you don't use brackets, you're going to get the wrong answer. So 346.8 divided by this stuff here, okay, and you get approximately 11.9. This is a length, so this would be meters. And you can put L back in this line if you want. Okay. And of course you can check. Okay, if you take this length and you multiply it by the width times the height, it should give you this original volume back. In fact, I'll check that right now. Yep, it works. Number 3, what is the radius of a sphere of volume 9,203 cubic centimeters? So if we use the formula that we derived before, the radius of a sphere is given by the cube root of 3 times its volume divided by 4 pi. Okay. Well, really volume is the only variable here, so I'm going to substitute that in. Okay. So this is 3 times 9,203 cubic centimeters. Extend that a bit more. Divided by 4 pi. So much like the square root option, you're going to work out everything that's inside here. You're going to get an answer. And then if you have a cube root button on your calculator, then you just apply that function as opposed to the square root. So I'm just going to work out my answer now. So 9,203 times 3 divided by, watch your brackets here. Okay. So I get 2,197 point blah 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 blah, and now I'm just going to take the cube root. And I get approximately 13, and this is a length, of course, so this would be centimeters. 13.0 centimeters. I'll put R back here. All right. Well, some of you might be wondering, how on earth can I get this if I don't have a cube root button on my calculator? Well, I will explain now how to do that. All right, so this is just an aside for those of you that don't have a cube root button. So in order for me to get this answer, 13, okay, I worked out everything inside here, and that came out to be, let's see, 2197.05. There were some more decimals. Okay, but if you don't have a cube root button, you need to make use of your power button. So depending on your model, it could look like that. Okay, but you should know where your power button is, because you would have used it already. Okay, so it might look like either of those two. So with this number in your display, what you need to do is hit your power button and then open a set of brackets and then just type 1/3 or 1 divided by 3, and then make sure you close your bracket, okay, and then hit equals. Okay. And if you do it correctly, you should get 13.000 whatever. Okay, so play around with this, but make sure you can get this answer. If you're kind of wondering why on earth is taking the cube root the same as raising something to the power of 1 divided by 3, what does that even mean? Okay, well, I'm not going to explain that right now because that will be formally covered later on in the course. So for now, just use the result and it'll come in time. Number 4, calculate the height of a cone of radius 8 centimeters and slant height 17 centimeters. And then we're going to determine its volume. Well, this is a question where it's probably a good idea to draw a picture. So here's my cone. Something like that. And I'll label it with what I can. I know that the radius here at the bottom, that is 8 centimeters. No problem. All right, I'm going to need the height to find the volume of the cone, but I don't know what the height is. So until I figure it out, I'm going to label it as h. The slant height is given, though. That's this right here. That's 17 centimeters. Okay. Now the slant height, this is a value that we would use if we were trying to find the surface area, but this is a volume question. So I need the height. So hopefully you can see that I'm dealing with a right triangle. So I'm going to use Pythagoras. So I know we're in centimeters, so I'm going to leave the units out for now. I know that 8 squared plus h squared is 17 squared. Okay. This is 64. This is 289. And if I subtract 64 from both sides, I'm going to get h squared is equal to 225. But I want h. So that would just be 15. That's the square root of 225. And I'll put my units back. This is centimeters. Okay, so I need that. So now let's find the volume of the cone. So the volume of a cone is just pi r squared h divided by 3. So pi times the radius squared times the height, which I just figured out is 15. Okay, that's just the volume of a cylinder, but I want cone. So I'm going to divide everything by 3. All right, let's work this out. I get approximately 1005.3, and this is a volume, so this is cubic centimeters. I'll put the V in there. So there's my answer to the nearest tenth. All right. So this number here, of course, is an approximation. I just rounded it to the nearest tenth. Okay. But even before I rounded it, the big long decimal in my calculator screen, that was still an approximation. And that was because I evaluated pi. Okay, but pi is an irrational number. You cannot write pi in its entirety in decimal form. So another way of expressing our answer more precisely, in fact exactly, okay, is just ignore the pi for a second. Okay, we're not going to evaluate it, and we're just going to work out all of the other numbers. So 8 squared times 15 divided by 3. Oops. So that's going to give me pi times, that's going to work out to be 320, and that's cubic centimeters. Okay, but we're not going to leave it like this. Remember, whenever we multiply a number by some kind of mathematical symbol or a variable, Pi is not a variable, but it's still a symbol. We always put the number in front. Always. So I would say 320 pi, and then my units are cubic centimeters. So I'll put that here. So that is the exact form for the volume of this cone. Okay? And you can also check it. What's 320 times pi in my calculator? And I get this back. So this is approximate. This is exact.